3.6 Key Features of Graphs and of Functions, Part 2. So let's go over some vocabulary before we get started. So we have domain and range. The domain is the input or the x values. So it's what you're plugging in. The range is the output or the y values. So the y values would be your answer. So after you plug in whatever x value you have, and then you get the y value for the answer, which is the output, the answer that comes out. Increasing intervals, so as the x values are increasing, which means they're going to the right on the x-axis, the y values also increase, which means they're going up on the y-axis. So you'll have a line that looks like this. And then for decreasing interval, as the x value increases, the y values decrease. So that means you're going to have a line that looks like this on a coordinate plane. So for example, if you think about increasing, it could be every hour that Joey works at Subway, he earns $5. So as the hours are increasing, the amount of money he's earning is increasing, so that line is going to go up. But then if you think about here, on the amount of food in a food bowl when you give it to a dog, so when you give the dog the food bowl in the beginning, they're going to have the most amount of food, but every minute that goes on, the food is going to decrease as the dog is eating, so that's why the line goes down. So the relative maximum, the point on the graph where the interval changes from increasing. Let's change our color. Or not. Let's do black. From increasing to decreasing. And then relative minimum is the point of the graph where the interval changes from decreasing, its exact opposite, to increasing. And let me explain what that means. So your relative maximum and minimum are points on a graph where they might go, they might be one of the maximums and one of the minimums, but they're not the absolute maximum or minimum. So if we have a line that looks like this, you've got a couple different points here. We have one of these, that's a maximum. Here's a minimum down here. Here's a maximum. Here's another minimum. And here's another minimum. And here's another minimum. So we've got some points here that are actually minimum or maximums. That's actually not. Let's get rid of that one. This end here would be the minimum. All right, so looking here, you can see that from this point, this is the highest one. So this would be the absolute maximum because it's the highest point. And then this is going to be a relative maximum. I'm just going to abbreviate relative max because this is not the highest one. This one is. So this is just a relative one. It's another maximum point, but it's not the largest one. And then down here, you can see that this point is a minimum. However, it's not the lowest point. So this, again, is just going to be a relative minimum. However, if you see here, this is the lowest point that it goes to. So this is going to be your absolute minimum because that's the lowest point. That's the absolute minimum that line ever goes to. And then over here, again, this is just going to be another one of your relative minimums because there are lower points than that. All right, so define the domain, define the range, where's the graph increasing, decreasing, and identify any extremas. All right, so define the domain. So domain, we read our graph from left to right. So we're going to read it in this direction. So as you're looking at this, you can see this line is going down, then it turns at this point and starts going back up on the other side. So this is our decreasing side. So first, the domain are going to be all of your x values. Well, I can see right here that this line has arrow going out this way and an arrow going out this way, which means it goes on forever. So that is all real numbers. And how you write that is you're going to write the brace that we talked about before that kind of looks like a face. Then it's going to be x such that, and that's how you say that, x in a line, x such that x is the set of, which is this little e that has a rounded e, all real numbers. And you write like that, 2 lines and then an r over the top. And then you put the other side of the brace. So x such that x is the set of all real numbers. And then for range, we have only going down to 0, but it also goes up to infinity all the way above that. So for range, it's going to be all positive integers. Actually, all positive real numbers. Sorry about that. All positive real numbers. And so you're going to write that with your brace again, but this time we're writing y because it's range. So y such that y is greater than or equal to 0, because it doesn't go below the x-axis line into the negative y values, it stays above. So y such that y is greater than or equal to 0, and then you put your braces around each side. And where is the graph increasing? So the graph is increasing from this point on. So we're going to start at 0. So we have a brace. And they're asking where it's increasing. We're talking about the x values. So x such that x is greater than 0, because that any point from here on is increasing. And then you just put your brace. And then for decreasing, well, we're talking about this side of the graph. So we have a bracket, and it's y. I mean, I'm not, why did I say y? Why did I say y? Y, it's not y, it's x. X such that x is less than 0, because it's on the left-hand side. And then for any extremas, so extrema again is just talking about any point that's really high or really low, and it can be either relative or absolute. The only one that is on this is right here at 0, 0, and that is a minimum because it's the lowest point that this line will ever go to. So that's a minimum. And you could say an absolute minimum because that's the lowest point that it is, and that's at 0, 0. And then define the domain again. So we have our line is going to be slowly increasing and keep increasing and eventually go to infinity. And then again, to this side, it's going to go to positive infinity. So we have all real numbers once again. And how you write that is your brace. And it's x such that x is the set of all real numbers. And then you put the brace again. Define the range. So we're looking at the y values. So the y is never going to go above 0, but it's going to continue to go to negative infinity. So how we write that is your brace again. And we're talking about range, so we do y such that y is less than or equal to 0, and your end brace. Then where is the graph increasing? Again, we're reading it from left to right. So as we read this, it's increasing on this side, and then it turns and decreases on the other. So it's increasing from brace x such that x is less than 0, end brace. So anywhere from here to the left of 0, it is increasing. But when it gets to 0, then it goes right back down again. So that's why we're going to write for this one, x such that x is greater than 0. And then identify any extremas, relative or absolute. And this is our extrema. So we have an absolute maximum at 0, 0 again. And then we got a thunderball roller coaster graph. So define the domain. So we have domain again is your x values. So we start with the face, x such that, and you're going to put x in the middle with a less than around it. So x is in between, and our x value starts at 0 and ends at 1250. So we're going to put 0 here and 1250 here. Then you put a brace. So for the range, so again, this is your x value. So it's starting at x equals 0 and it ends at 1250. So you're putting your x in between those two numbers. And we use less than or equal to around your x to do 0 is less than or equal to x, which is less than or equal to 1250, which just means x is somewhere between 0 and 1250. Then the range is talking about your y values. So look at your graph. You can see that the graph starts at 10. Again, this doesn't go below 10 either. So we have 10 up to whatever the highest point is, and the highest point goes up to 110. So for this one, you're going to write brace y such that 10 is your lowest, and then you have your less than or equal to y, less than or equal to, because that makes y in between, and the lowest point is 10, the highest point is 110. So y such that y is in between 10 and 110, because 10 and 110 are the lowest and highest values of your y-axis. And now we have to identify the extremas. So those are your relative minimum and maximums. So looking here, I can see that this is one of them, 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 and this is one of them. So immediately I want to identify the absolute minimum and maximums. So my absolute ones are going to be, this is the lowest point, which is the same as this one. However, this has a different x value. This is my highest maximum. So down here I'm going to write absolute, and you can write a relative if you want. You can make a little table to organize the information. Then over here we can write minimum and maximum. So our absolute minimum, which is the lowest point that it ever goes to, is going to be 0, 10. We change the color. 0, 10. And, that's my and sign, 1250, 10. And then my relative minimums, which means another minimum but not the lowest one, will be at 550, 30. And my relative maximums, or absolute maximum, which is the highest one it will ever go to, is at 250, 110. And my relative maximums, which is another high point but not the highest point, is at 890. So we've got two absolute minimums, one relative minimum, one absolute maximum, and one relative maximum. So you've got 4 different points here, actually 5 different points here that are your extremas. So make sure you identify all of them. Go Seahawks. Woo!